Hello everyone. So today we'll be starting with lab session 8. So what we have in lab session 8 is how to compile multi-file projects in C. So this will be the topics. These are the topics that we'll be studying. So we'll start with header files in C. Then we'll see how to write modular programs. Then we'll create a C project and compile multiple .c and .h files to create a single executable. And after that, we'll write a shell script to combine all these Unix commands into a single script and run that script. So let's start with creating a directory. So let's create a directory for lab 8. Yeah. So I'll open Sublime Text also. So let me adjust the screens accordingly. Let's open Sublime Text. And we want ourselves to be in lab 8. Yeah, so this is lab 8. Let's close this and move this here. Yeah, so we are in lab 8 now. So let's start with the first exercise. So first exercise introduces us to header files in C. So you must have seen files with the .h extension in your C programs. So these .h files, these contain some global variables which you want to use in your programs. There may also be macro definitions, and there may also be function declarations, which you call function prototypes. And then you define those functions in another file, in another .c file. So you keep the function prototype, the global variables and macro definitions in the .h file, and then define the function and use those global variables in the .c file. So there are two types of header files. One is what the programmer writes, and one which the compiler provides to you. So how do you include a header file? You include a header file by using the hashtag include preprocessing directive. Like you must have seen, we include hashtag include stdio.h. We'll see which functions stdio.h gives us. So as I mentioned, including a header file lets us use the functions which we have declared in the .h file, and also the constants, macros, and global variables which we have defined in the header file. So we'll see how to use these header files in a .c file. Before that, as I said, there are two types of files. One which comes along with the compiler, and the other which the programmer writes. So this is the syntax in which we use the header files which come along with the compiler. As an example, we have the stdio.h header file. So this header file gives us functions like printf, scanf, and to include this, we write hashtag include stdio.h in this manner. And upon seeing this, the compiler searches for the file named stdio.h in the list of the system directories that it has. And when we create a user-defined header file, we include myfile.h. Let's say the user-defined header file is myfile.h. Then we include it in this manner, writing the name in double inverted commas. So upon encountering this, the compiler will search for the file named myfile.h in the same directory as the C file is in. So you'll understand all this better when we do an example. So let's start with an example. Let's say we have to write a file named search version1.c. So let's create this file in the Sublime text editor. And let's save this with the name search_1 version.c. Okay, so I wanted to save this. Wait a second. Yeah, so we have saved this here. So there's the name's a bit different. Search underscore version 1.c. Let's change it to that. Yeah. So let's copy paste this code. Yeah. So we have copied this code here. So what is this code for? This code is for searching an element. So as you can see, this is an array of size 10 and we are searching for the element 32 here. If we find the element, then we set the found flag is equal to 1. Otherwise, the found flag remains 0. So inside, we'll run a for loop for the size of the array and we are calculating the size of the array by dividing the total size of the array by the size of one element of the array. So we'll iterate the for loop, and if the element is found, we'll set the found flag to 1, and at the last we'll check if the found flag is 1, then it means that our element was found. Otherwise, if the found flag is 0, that means the element was not found. So now let's try to compile this. So I'll check if, so I'll first navigate to lab 8. I'll check if the file is there. Yeah, so search underscore version 1.c is there. I'll compile this using GCC command. Search underscore version 1.c. Yeah, so as you can see, the a.out file gets generated, so the file compiles. One another option is that we can give the file a name which we desire. So if we use GCC search underscore version 1.c and use the -o flag and then give the file a name, let's say exe1, then you'll see that a file named exe1 gets generated. This is the exe file. So you can give the exe file a name other than a.out by using the -o flag. And when you run exe1, you can see that the element x is found in array1 at position 3. So this file runs. Now let's say you have to create another file, search underscore version 2.c, and the entire programming logic is same. Just the array changes and the element which you have to search changes. So one practice would be, like, one way of solving this problem would be to write the entire logic again, this for loop thing, and then searching if the element is present or not. If present, then print that the element is present. Otherwise, print that the element is not present. So the one way is to write the complete code again. So let me copy this also for the sake of completeness. And let's create a new file and save it as search underscore version 2.c. And then I'll paste this code and let's run this once. So I'll just change the exe file to exe2 and the file name to search underscore version 2. So the exe file gets generated. Let's run the exe file. And you can see that this code runs. But you may notice that this creates duplicacy. Like You are rewriting this whole code just because the array and the element to be searched was changed. So instead of this approach, what we can do is that we can define a function search and write the logic inside it for searching an element. And we call this function once for array 1 and the next time for array 2. So this way, our code logic is written only once in the search function. And what we are doing while calculating the output for array1 x and array2 y is that we'll first call the function search for array1 and x, and then it returns according to the output. And then the next time, instead of writing the function again, we are just calling that function. So this way is called modularizing your program. So instead of writing the logic two times, once for array1 and once for array2, you are writing the logic inside a function, and then you are just calling that function twice, once here and once here. So let's copy this code also. In a new C file named search underscore version 3.c. And then I'll copy paste the code here. So as you can see, this search function. So first, you can see that this is the prototype of the search function. Like it is the function definition. It defines the function name, the function return type. It returns an integer value and the parameters list, which we call the signature of the function. So the first element should be an integer type array, the next element should be an integer type size, and the next element should be an integer type element. And then after defining the prototype, we'll write the definition of the function. So here is the definition. The logic remains the same. We'll run a for loop from 0 to the last index of the array, and we'll return the index if we find that the element which we are searching is there inside the array. So ELE is the element to be searched, size is the size of the array which we are passing, and array is the array. So we'll iterate through all the elements of the array and check if the element is present here and return the index if it is present. And while computing the answer for array 1 and array 2, instead of writing the code logic again, we'll just initialize array 1, initialize x, and then we have to calculate the array size using dividing the size of the total array by the size of one element. And then we'll just call this search function, passing in array 1, the size of the array which we calculated here, and the element to be searched, which is x. And this will return the index if the element is present in the array. Otherwise it will return -1 if the element is not present. So we'll check if the element is greater than or equal to 0, that means the element was present, and we'll output the element x was found at the required position. Otherwise, if the element index is less than 0, then we'll print the element x is not found in array 1. The same thing we'll do for array 2. Instead of writing the logic again, we'll call the function, pass in the array size again, which we calculated here, and the element to be searched, which was y. And then again, we'll return the index if the index is greater than 0. And if it is less than 0, which means it is -1, that means the element was not found. So let's try to see if it returns the same output as the previous file. Okay, so there is an error in line number 5. Okay, so this was a part of the comment, so I'll backspace it. Now it should work. Okay, so I also have to save this. Let's compile this again. It gets compiled. Let's also clear up the terminal a bit, and we'll run exe3 file, and you can see that the output is the same. Let me also show you the output of the exe2 file, in which we rewrote the logic twice. So see, the output of exe3 and exe2 files is the same. The 2 version was where we wrote the code logic again. See, you can see the for loop here written again. So modularizing allows you to write your code in a fewer number of lines than you were using before. So let's go to our lab sheet once again. Okay. Now there is a case where you want to use this search function in some other .c file. Like here, you have defined the search function inside this .c file and you're using inside this .c file only. Let's suppose a situation where you want to use this search function in some other file. Let's say it is named search underscore version 4.c. So normally what will you do? You'll say define this search function there again and then again call this function in the main function. Now let's say you have thousands of such files where you want to use the same search function. So you will write the search function, you will write the same search function 1,000 times in each of those files. So that is again not a good practice because you are duplicating your code. So instead of that, what we can do is we can create a single file containing this search function and we'll use a header file to write this. So we'll create a header file where we'll write this search function and then we'll include that header file inside all other files which need this search function. So let me show you with an example. We'll create a search.h which will contain the function prototype. So let's first create the search.h file. I'll create a new file which is search.h. Okay, and I'll just include the function prototype here. That means the function declaration, not the definition. So I've included this and I'll define the function in another file named linear search.c. So this linear search.c file will contain the function definition. And how will it know which function's definition is this? So we'll have to include the search.h file also to tell this file that this definition of search function is that of the search function declared in search.h. So for that reason, we are including the search.h file. So let's create a linear search.c file also. Save as we've already done. We need to create a new file and we'll save it as linear search.c. And again, we'll use the function definition this time, not the function declaration. And I have referenced the search.h file to tell it that you need that this is the definition of the function declared in search.h file. Okay. So now let's create another file, search underscore main.c. This is the file where we want to use the search function, but we are not defining the search function in this file itself. We'll include it from the header file which we have declared it in. So yeah, again, this is the search underscore main function. First, let us copy this. Yeah. So we need to use the search function to search if the element X is present in the array 1. So we are calling the search function here. Again, we are calling the search function here. So we have included the search.h file because it contains the definition of the declaration of the search function, not a definition. So it just knows that search function is the element which is the function which was declared here. But in order to use its, in order to use its definition, we need to tell it that the definition is contained in linear search.c. So we'll have to link these two files, search underscore main.c and linear search.c, because search.h just contains the declaration and we want to use the definition of search which is there in linear search.c. So for doing that, we'll need to link the two files, search underscore main.c and linear search.c. So let's see how this is done. So for linking, we'll first need to compile linear search.c and then we'll compile search underscore main.c. First, we'll have to compile these files separately and then we'll link these two files. So first, let's see all the files are there. Then we'll compile linear search.c. So also using the -c flag generates the object files corresponding to this .c file. So in the process of compilation, the .c file first gets converted to a .o file and then to an exe file. So if we use a .c file, then we'll get the .o file. If we don't use it, then it directly gets converted to the .exe file. So since I'm using this, a .o file will get created. So if you will see linear search.o file gets created. Now we'll compile search underscore main.c as well and create the object file for that. I missed the -c flag here. So I'll create the object file for this as well. So see, the object file for search underscore main was created. Now we need to link these two files. So the command for that was gcc -o, the name of the file that we want to give to the exe file and the individual .o files. So I want to give the name search underscore exe to the combined executable and then write the name of the object files. So this process will link the two C files which I had written the code for. So, okay, so there was a typo here. So you will see that the search underscore exe file gets created. And when I run this file, search underscore exe, you'll see the same output as before. If we run exe3 and exe2. So this completes your file linking part. So we had seen the linear search.c function, which searches an array from left to right. Now we can also use a function linear search. So we can also use a file named linear search r12.c, which searches the array from right to left. So you can see that inside here, we are iterating from size -1 to 0. And then checking the same thing if the array element is equal to the element which we are searching for. So let's create this file too. So what was the name of the file? We have to save this with the name linear search r2l.c. So we'll save it in this format and then just copy the code from here. So now we can use this file for our purposes. So let's first compile this linear search r2l.c. This will create an object file for this. This is the object file. And now we can link this to create a new exe file, search underscore exe. Let's name it search underscore exe2, and then link the object file for linear search r12.o with search underscore main.o. So this file gets linked, and you can see that search underscore exe2 gets created. And then we'll run this exe file to check the output. And you can see again we get the same output. Just the file which we used this time was linear search r12.c, and the function checked from right to left instead of left to right. So also, if we use both linear search.o and linear search r12.o, then we'll get an error, because then we'll have two definitions of the search function. So the compiler doesn't know which definition to use. So let me show you by writing the commands. So we are linking search underscore main.o, linear search.o, and linear search r2l.o. So you can see here the compilation error, multiple definition of search. So the compiler doesn't know which search function to use. Also, there can be another type of error in which you don't include the file which contains the function definition. So let's say I only compiled search underscore main.o. So then you don't know which function definition to use. Like, you don't know where the search function comes from. So again, you get a compilation error. So okay, so wait, I didn't type in the exe file name. Let's do this again. Search underscore main.o. Okay, so first we'll have to compile search underscore main.c again, I think. And let's now try to use the search underscore main.o object file alone without linking with any other file. Then you will see this error coming, undefined reference to search, which means it doesn't know which search definition. It doesn't know what is the definition of search, because you haven't linked the definitions of search with this file, because the definitions of search were there in linear search.c and linear search r12.c. Also, there can be another type of error in which you don't include the file which contains the main function. So let's see which files are there. So suppose you try to compile the linear search. Let's name it exe underscore linear, and I'll use the linear search.o object file which doesn't contain the main function. So see, you get the undefined reference to main, because there is no main function inside linear search.c, so you can't compile it. You need to contain at least one file in your command which has a main function. So you'll have to use one file which contains a main function, otherwise you will get this error undefined reference to main. And then there can be another type. So these errors are called linker errors. So you can try reading more about linker errors. I showed you some of the errors and how they are and in which situations they can be generated. Also, there is another type of error in which you include the correct header files, but the linker does not know the correct part to the library. So this may be because of some issue during the installation of a compiler. So that's it. These are the four types of errors which can get generated due to issues in linking multiple files together. So this is what we did till now. We wrote our program in a modular way where we first wrote the functions inside the search underscore version 2.c, search underscore version 3.c. We wrote the function definition and then we used the function instead of duplicating the code. Then we use this search function across multiple files by writing the declaration in a header file and implementing it in another file, and then compiling and then including the header file in the file which we want to use the function in, and then linking the function definition file and the file where we want to use the function together. And then at last we learned about the linker errors. So you can reduce all these you can reduce all the hassle of writing the commands by writing all these commands into a single script file. So instead of running all these commands separately, you can write all these commands inside a script file and then you can run the script. So let us create a myscript.sh file. We'll name it myscript.sh, and then I'll copy all these commands. So again, as earlier, these are the same commands which we were using earlier. So first we were compiling the linear search.c file to produce an linear search.o object file. This will produce search underscore main.o object file, and then we'll name the file which is generated by linking the two object files search underscore exe, and then we'll use the two object files to link it. And finally, we need to run this search underscore exe file. So for running this script, we'll simply type in sh myscript.sh inside our terminal. First, let's see. We have this file here, and we'll just run this script file. And you can see you get the same output as before. So this is another way of running all these commands. So the script file is useful for if you want to run a sequence of commands and you don't want to write it one by one. So instead of writing the commands one by one into your terminal and running them, you can write all your commands inside a single script file and then run that script file. Also, you can remove all the object files and exe files once before running the script file if you want, because you can see that there are a lot of object files and .exe files in the current directory. Uh, yeah, not .exe, just exe. And now you can see that all the .o files and exe files got removed. And again, you can try to run the script file so that you know that it creates all the intermediate files. And you can see it creates the intermediate files again, and the output is the same. And again, you get the .o files and the exe files as required. So yeah, this was it. The additional practice exercises for you to solve. Thank you.